Let's start with a quick introduction to Azure Functions. So first of all, what are Azure Functions? Azure Functions are a serverless compute resource. Let's break this down in two parts. So the compute resource part is fairly straightforward. It's just a resource that allows us to run code. It usually takes some input and it produces some output, whether it's something that gets returned to the user or some externality like writing to a database, for example. We'll touch on inputs and outputs of our functions later on. The part I want to focus on is the serverless part. So what is serverless? Serverless is pretty much the latest trend in cloud computing. It means that we don't have to worry about the infrastructure, so we can focus primarily on the code. It's very common to see serverless resources in event-driven architectures. The biggest features here are that serverless compute is on demand, so you only pay for what you use. It offers automatic scaling, and you don't have to manage the infrastructure, so you can focus on the code. Let's go through each of these. So the first part, the on-demand part. Let's say you have an app running on a VM, then you would have to pay for the time that that VM is up. So regardless whether if that is processing data or if it's an idle resource, you would have to pay for the time that you have it running. In serverless, that's not the case. You only pay for the time that the resource is actually doing work. It's actually computing something. So that's a big advantage in cost management. The second advantage is the automatic scaling here. This is a big plus. This is one of the things I like the most. If you ever had to deal with scaling a cluster, let's say a Kubernetes cluster or something like it, you know that it's a time-consuming task and it takes some time to get right. Like there's a lot of tweaking and tuning until you get the scaling you need. With serverless, you basically get the auto-scaling for free. The last part is the no infra management, so that you can focus on the code. So take this with a grain of salt. It is true that you don't have to manage the infrastructure, but still there's quite a lot of configuration to be done with your Azure function. Now, credit where credit is due. With the default settings, it's probably going to be fine for POCs and like testing things out. But once you have things in production and you want to tweak them and optimize them, you're going to spend some time doing some tuning there. So while it's true that it allows you to focus on code, it's not like you have to manage absolutely nothing and you just deploy it and it runs. There's some tweaking there to do. Serverless resources also have their cons, but I'll leave those for a later discussion. What I want to focus on right now is the part of the event-driven architectures. So Azure Functions are event-driven resources, meaning that they run whenever something happens, this something being an event. They are triggered by an event. Here we can see that these Azure Functions have inputs and outputs. They are usually called bindings. An input binding is usually called a trigger because it's what triggers the execution of the function, and the outputs are called output bindings. There are many different kinds of triggers, but the most common are database-related triggers, request-related triggers, and message queue-related triggers. The same goes for the output bindings. So this could be, for example, a database being updated, an incoming request, or a new message arriving in a queue. And you can mix and match these, so you can receive a new message in a queue and write something to a database. You can receive a request and put a message in a queue. You can also have as many inputs, as many outputs as you want. So input and output bindings are very, very flexible. There are lots of input and output bindings, but these are around the most common. This flexibility makes Azure Functions very, very powerful, as they can be used in many different scenarios for many different applications. Now that we've seen what the Azure Functions look like high level, let's see the implementation. What does that look like? First, we're going to need a resource group. This is just a logical grouping of our resources, and it will hold all the resources we need to create our Azure function. Within this resource group, we're going to create the app service plan and the storage account. The app service plan basically defines the compute plan tier. There are two main groups when it comes to service plans. You have fixed service plans and consumption service plans. Fixed service plans are the more traditional ones, where you have fixed resources, so you pay a fixed fee. They're not truly serverless. Consumption service plans dynamically allocate the resources. So this is the true serverless option. They are the ones that offer auto-scaling and this pay-as-you-go structure. We'll see how to create function apps with both the fixed and the consumption tiers here, but in both cases, there are different tiers for these service plans. So usually the more expensive tiers have more features, the less expensive tiers have less features. Moving on to the storage account, this is basically where your functions, files, and metadata live. The concept is simple enough, but this is key to the serverless architecture. So functions are serverless resources, meaning that they are stateless by design. They don't save, they don't store any data. So these compute resources are created and destroyed as needed. For example, they are created when our function is scaling and when our function is called after being idle for a while, and then they are destroyed when they are no longer needed. Lastly, we have the star of the show, the function app. The function app is an app where the functions live. We can create many functions within a function app, and each function will have its own endpoint. And that's the basic anatomy of an Azure function. That's all the resources we need to create in order for our Azure function to run. Let's get hands-on and let's create them. Before I do any of that, I'll check my Azure configuration. Let's run Azure account show here to check that I'm in the correct subscription, and I can see that I'm logged in, I'm in the learning subscription. But just in case you're managing multiple subscriptions like I am, you can use this command, the Azure account set command, to change your subscriptions. So right now I'm changed to my personal subscription and we can see I'm there, but let me change back to my learning subscription. Just one important thing about the commands I'll be running here. The first is that I'll be using a lot of copy-paste commands because I have tried them all previously, and don't worry about copying them from the video. They will all be available in the GitHub repository that will be linked in the description. Also, commands and configurations change over time, so the important thing to understand here is the concept and the flow, not the commands themselves. Let's start by creating our resource group. Here in my Azure UI, also known as the portal, we can see that in my learning subscription, I only have one resource group, and that's the default resource group. So let's create another one. The command to create a resource group is here, the Azure group create command. This command takes two arguments. The first one is the location. In our case, it's going to be East US. And the second one is the name. In our case, it's going to be Azure function RG. RG stands for resource group. Once we get this output, that means that the resource group has been created, that the command has run successfully. So let's move on to my Azure account to check if it's there. And here it is. Now we have our new resource group in my learning subscription. Now, within this resource group, we're going to create our storage account. If this is your first time creating a storage account in Azure, you might need to enable Microsoft Storage as a resource provider. This basically means telling Azure that you want to enable storage accounts in your subscription. We will do this by running the Azure Provider Register command using the namespace Microsoft Storage. I'm not going to run this in my account because I've already done this in my subscription. And you can check your registration state by running Azure Provider Show command. In this case, we're going to pass the namespace Microsoft Storage because that's what we're looking for, and registration state as a query. When running this command, we can see that it comes back registered. This means that I'm good to go in my subscription. So once we're done with that, we can go ahead and create the storage account itself. We're going to create it using a command very similar to the one we used to create the resource group. We're going to create it using the Azure Storage Account create command. For the arguments, I'm going to be using the shorthand notation, so N stands for name. I'll name it storage function app 1. G stands for resource group. I'll use the resource group that we just created. And L stands for location. I'll use the East US location, which is the same location as the resource group. The interesting part here comes to the SKU. Whenever you see SKU in Azure, this will be related to the pricing tier. In this case, I'll be using standard LRS, which is the cheapest one. You don't need to worry about this for now. One important thing related to the arguments is that the name of the storage account needs to be unique across all of Azure, not only within your subscription. So it's relatively common to get an error saying that the name is already taken. Just when that happens, just change the name and try again. As you can see here, the one we tried, it's already taken. So I'm just going to add some numbers there. Let me add maybe 1, 2, 3 and try again. And it's running. And once we get this output, it means the storage account was created successfully. So we can move on to creating the service plan. Before we create the service plan, we need to register the Microsoft Web Resource Provider in the same way we did with the Microsoft Storage Provider. In my case, I'm not going to be registering this. I'll just check that I have it registered with the same command that we ran before. Once I run this, I get the registered state back. That means we're good to go to create the service plan. And just like everything else, we're going to use this app service plan create command. So for the name and resource group arguments, they're going to be pretty much the same as before. What I do want to focus on is this SKU argument. We're passing B1 here, and again, same as with the storage account, this is related to the tier. Now, the B1 tier is not the consumption plan, it's a dedicated plan, the fixed plan. B1 is the cheapest one of the dedicated plans. There is a free plan, but function apps are not supported in the free plan. We'll see how to create a consumption plan based function app later on. So the last argument here is the isLinux argument. This is a flag that tells Azure that we want to use Linux-based compute resources. This is important because our function app will be running Python code, and Linux is the recommended OS for Python. If we were using a C#, for example, a .NET-based application, we could use a Windows-based service plan. This output tells us that the resource was created successfully, so our service plan is there. Now, let's move on to our Azure portal to check the resources we just created. Here in our Azure function resource group, we can see the service plan and the storage account we just created. So we can go back to the command line and create the last piece, the function app itself. Again, as we did before, we're going to have to register some resource providers. These resource providers are called operational insights and just insights. Again, with the same commands, we can check if they are registered. Once we have checked for that, we can go ahead and just create our function apps. Creating our function app is very similar to everything we created. We're going to be using the Azure function app create command for resource group, plan, name, and storage account. It's pretty much the same as we've seen so far. The only specific arguments are the runtime argument, the runtime version, and the functions version arguments. In runtime, we're going to be using Python. In the runtime version, we're specifying that we want Python 3.11, and the functions version is just the Azure functions version we're going to be using. As the recording of this video, the latest version is version 4. Once again, this output tells us that the function app was created successfully, so let's move to the Azure portal to see it. Oh, here it is, the resource group. Let me refresh that, and there's our function app within our resource group. Let's go check it out. So we have just created this function app, so Azure's allocating the resources for it, so it's normal if it takes a while to load. A few minutes later, we can see that our function app has loaded, and here under the functions tab, we're going to find all the functions we created. At this time, we haven't created any, so it's okay that this is empty. Here we have a URL for convenience where we can check that our function is running. Here we can check our functions files. At the moment, there should be only a host file, which holds some configuration for the function, nothing special. Here it is. And here we can check the logs. we won't see anything because nothing is happening with our function app. And here we can see the environment variables that we will be using at runtime. That's pretty much the basic tour around a function app. And for now, we're going to wrap it up here. Before we leave, we're going to destroy all the resources we created so as not to incur in any unwanted costs. For this, Azure has a very convenient command which allows us to delete resources. And remember how we talked about how resource groups just group resources logically together? Well, we can then delete just a resource group, and every resource within that resource group will be deleted as well. We can do that with this command here, the Azure group delete, and we just pass the name and yes, so that it doesn't prompt us, and this flag here, no wait, that basically makes the command asynchronous. So it makes the command to return immediately to allow us to continue using the command line, but this doesn't mean that the execution has actually finished. It just sent the command to Azure to delete it, but that doesn't mean that the resource has effectively been destroyed yet. For example, we can go back to the Azure portal and we can see that the resource is still there. This will take a few minutes to execute, expect 5 to 10 minutes maybe. So we're going to wrap it up here and see you in the next one.